Ever consider how everything we know, including time, planets, galaxies, and even light, could exist inside something that shouldn't allow anything to escape? The possibility that a black hole could contain our universe is among the most controversial theories in contemporary physics. Indeed, what has long been thought of as an unreachable abyss may in fact serve as a conduit for the development of alternate universes. This theory pushes the boundaries of our knowledge and poses difficult philosophical problems to science. What if our Big Bang was only the birth point of another universe's demise? When we go back to the fundamental characteristics of black holes, the idea becomes more compelling. A singularity, a location where density is infinite and the laws of physics just stop working, is created when a particularly massive star collapses under its own weight, according to Einstein's general theory of relativity. Imagine now that this singularity is not a dead end, but rather the start of something. A space-time explosion, a new universe emerging from the devastation of another. Does that seem like science fiction? Maybe. However, some scientists not only think this is conceivable, they also believe it to be the most elegant explanation for a number of anomalies that we still don't fully comprehend. The idea of the universe itself ceases to be unique when viewed from this angle. Alternatively, we envision a multiverse where every black hole is a cosmic seed that creates its own realities according to its own set of physical laws. For instance, this would explain why some of the constants in our world appear to be so precisely calibrated to support life. Maybe there are an endless number of universes, and ours is just the one that turned out right. This would be a cosmic chance that resulted from the collapse of another universe. Moreover, this theory provides an unanticipated link between general relativity and quantum mechanics, two of the most expansive but still poorly understood branches of physics. The notion that we are inside one of these black holes may hold the key to eventually bringing these two forces together. A black hole's interior might be an expanding world similar to our own, rather than merely a prison without light. Instead, it might belong to us. The question that will inevitably arise is how we can determine whether this is accurate. Everything within a black hole is, after all, cut off from the outside world. Or is it? Strange behavior in the geometry of space-time, cosmic background radiation, and even the distribution of dark matter has been discovered recently. These findings may serve as indirect indicators that we are actually living inside something far bigger than we previously thought. If this is the case, then whether or not we are within a black hole is not the most unsettling question of all. Is there anyone out there who knows? Additionally, are they able to see us? Subscribe to the channel to get weekly documentaries. The singularity, which is at the core of a black hole, is so enigmatic and mathematically ludicrous that it cannot be adequately explained by even the most sophisticated theories. All of the black hole's mass is concentrated in that minuscule, dense point. More than that, though, it is the location where space and time physically become incompatible. What takes place within a singularity? Does time keep going by? Does space still exist? Or does it just stop making sense? The singularity can be compared as a fissure in reality, where the established principles of physics break down. Everything becomes ambiguous, limitless, and unfathomable, in place of having precise measurements of time, distance, or energy. And for good reason, it is at the center of so many hypotheses concerning the universe's origin. It seems that a singularity, the first instant when the cosmos was compressed to a very small point before starting to inflate violently, was also the source of the Big Bang itself. The similarities between the singularities of a black hole and the Big Bang are remarkable. extreme densities, ridiculous space-time curvatures, and the existence of powerful gravitational pulls are all present in both. Then, wouldn't it make sense to believe that one could serve as the entryway to the other? That the other side of a black hole's singularity is the Big Bang. The concept of time adds even more intrigue to this thought. As one gets closer to the event horizon, time slows down for someone plunging into a black hole. That moment appears to be frozen to an outside observer. Imagine now that the history of a new universe is created by time restarting, or possibly extending indefinitely within that warped perspective. The singularity would become a fresh start rather than an end. According to a number of theoretical physicists, including Nikodem Popowski, a closed universe with its own space and time could exist inside a black hole and evolve independently of the parent world. We wouldn't be aware that we are the product of the collapse of a larger universe if we were living in one of those branches. What impact would this have on our existence, too? In essence, our current reality is only one of many that were created by various black holes in other universes. The multiverse's actual womb would be singularity, the place where everything starts and ends. Imagine a dark frontier where even light gives up to gravity, an invisible border in the cosmos. That is the black hole's edge, or event horizon. There is no way back, no way out, no way to redemption, so crossing it is like plunging off a cliff into the dark. From the outside, time appears to be slowing down. Everything falls apart from the inside out. Time and space take on different roles, and the future only leads to singularity. The most unsettling aspect? Black holes could not be the only objects with an event horizon. According to some scientists, the cosmos may have its own event horizon, a cosmic shell that restricts our ability to see, touch, and measure. As if we were imprisoned inside something bigger, gradually being forced outward, this would explain why the universe is expanding so quickly. This analogy between the universe and a black hole is mathematical as well as metaphysical. Density, duration, and energy exhibit comparable behaviors in both scenarios. The event horizon would be the exact edge of the universe we live in if a black hole is capable of holding a universe. Just like inside a black hole, nothing from the outside could get to us. What is on the other side of our cosmic horizon? Other universes, other realities, or perhaps the parent world that gave rise to our own could exist. The most interesting part, though, is that since signals cannot cross that boundary, we will never be able to tell if there is something observing from the other side. We do know, however, that the event horizon is a membrane between the known and the unimaginable, not merely an edge. The connection is chilling and obvious. Maybe no information leaves our universe, just as nothing can escape a black hole. Similarly, nothing from the outside could get to us. It is possible that the cosmic bubble in which we reside is actually the interior of an unseen gravitational colossus. The question still stands: if we are imprisoned within, is it someone or something outside? Albert Einstein, whose ideas revolutionized our understanding of the cosmos, is alone responsible for the entire notion that we inhabit a black hole. He introduced the theory of general relativity in 1915. It was such a potent equation that it permanently altered the geometry of the universe when it was put in writing. The theory explains how space and time curve in the presence of mass, in addition to describing gravity. And black holes are created by such great curvature. However, relativity also produces an odd scenario. It predicts that space can bend into loops, that time can freeze, and that there are places where equations explode into infinities. Those areas are known as black holes. Furthermore, the Big Bang, the beginning of our universe, behaves like one of these mathematical anomalies. This made theoretical physicists wonder, what if these singularities constitute a bridge to something else rather than the end of physics? Here's a drastic twist. Some mathematical models propose that black holes are universe constructors rather than destructive entities. This is what general relativity solutions like the Kerr and Schwarzschild models suggest. In certain cases, these equations continue and connect to other spacetimes, other realities, instead of ending in singularity. The notion that our universe might be the continuation of one of these solutions, the discharge of matter and energy into a new, emerging cosmos, was sparked by this kind of interpretation. An infinite tree of realities connected by gravitational curvatures might be created by each black hole in a universe, which could serve as the seed for a new universe within it. The sublime and science collide here. It's possible that we are not the original universe. Maybe we are just one part of a much bigger story that time and gravity have written. In addition to describing gravity, Einstein might have provided us with the blueprint for comprehending the formation, collapse, and renewal of universes. If this is accurate, we are a part of an equation. The Big Bang was long thought of as an absolute beginning, the emergence of space, time, matter, and energy from an unexplained cosmic explosion. However, what if this is incorrect? What if the Big Bang was the continuation of something that had already happened, namely the interior of a black hole in another universe, rather than the beginning of everything? This concept is incredibly transformative, in addition to being fascinating. According to this theory, we are the inside of a massive gravitational collapse that took place in an other reality. Imagine the following scenario. A massive star crashes in an old cosmos, forming a huge black hole. Space-time bends so much inside that a new volume and geometry are created, as well as a new universe. We own that universe. The Big Bang that we saw was not the exact beginning, but rather the point at which this new universe started to grow internally, while remaining enclosed by the old black hole's event horizon. One of the biggest enigmas in cosmology is resolved by this theory. What preceded the Big Bang? A cosmic cycle of birth and rebirth in which each world is born from the death of another presents an explanation that avoids complete nothingness if the solution is a black hole in another universe. A form of interdimensional recycling in which life is nourished by destruction and creation is produced by collapse. This perspective is starting to be supported by modern physics. According to models that combine general relativity and quantum theories of gravity, the Big Bang's singularity might be smoothed out. That is, there would be a smooth transition between two cosmic states rather than a point of infinite density. In what some theorists see too as the Big Bounce, a new universe would expand as a result of a black hole collapsing. However, how does this alter practice? Everything. It suggests that our cosmos is not separate nor unique. Infinite cycles of black hole formation could produce innumerable worlds similar to ours. The idea that the black holes we see in our universe can also hold whole universes with their own galaxies, physical laws, and other characteristics is arguably the most disturbing. Organisms. If this is accurate, the Big Bang is merely a link in an endless chain of existences rather than the beginning. A new age, a new opportunity, a fresh version of everything is born with every collapse. And what appeared to be the end turns out to be the most potent beginning. Have you ever seen the Matryoshkas, which are Russian dolls that fit inside one another. Imagine now that the cosmos functions similarly. Many theoretical physicists use this image to explain the idea of worlds inside universes, layered like cosmic layers. Every black hole would serve as a portal to the subsequent level. Our own cosmos might be one of the tiniest dolls, tucked away inside a gigantic building that is invisible to us. In addition to being lyrically lovely, the concept of nested universes is derived from general relativity's mathematics. Our world might be contained within the curved interior of a wider reality, invisible to us but crucial to our existence, if each black hole has the capacity to create a new spacetime. According to this scenario, additional black holes would be incubating their own creations within our universe, and the Big Bang would be like the opening of the next doll. A hierarchical multiverse is produced by this layered structure, where the laws of physics might differ between universes. In another universe within another black hole, things that are constants to us, like the force of gravity or the speed of light, might be entirely different. Every layer has a unique identity and past. We are a chapter in a book that we haven't read through to the end. Our perception of reality is drastically altered by this vision. We envision a fractal cosmos, a self-replicating, endless structure where each point of collapse gives rise to a new expansion, rather than a flat, isolated universe. As with Matryoshka dolls, the smallest can be the most intricate, and the line between inside and exterior blurs, with what is inside potentially containing more than what is outside. If this seems unrealistic, keep in mind that there are black holes that might hold thousands of galaxies, each with a mass millions of times that of the Sun. The possibility that such gravitational energy could produce vast, self-regulating, and whole realities is plausible. And possibly, without even realizing it, we are living examples of this, inhabiting one of these enormous cosmic dolls. The final vision is both poetic and unsettling. The universe is not a location, but rather a living structure made up of layers upon layers, where every new collapse is a birth, and where maybe a black hole in our universe will eventually give rise to the next chapter. With other creatures, laws, and inquiries. The notion that space is flat, straight, endless, and predictable is our biggest delusion, but that is not how the universe operates. According to general relativity, space may bend, twist, roll up on itself, and even curve, much like a piece of paper that has been twisted into a tube. Furthermore, that geometry stops making sense when gravity reaches extremes, like within a black hole, giving rise to what physicists refer to as non-Euclidean geometries. An entire universe can fit within a black hole because of these warped spaces. Even while the black hole's mouth appears to be modest from the outside, the internal volume within these curving regions can be enormous. It may, in other words, be larger inside than outside. This idea is scientifically feasible and consistent with Einstein's equations, despite the fact that it totally contradicts human intuition. Consider a magic bag to better comprehend it. It appears little from the outside. However, you discover that it is nearly limitless when you reach inside. In a black hole, space-time functions similarly. The universe's fabric is stretched by extreme gravity to the point where inner regions are formed that are totally cut off from the outside world. It's as though you entered a regular door and discovered a whole universe waiting for you beyond. Theories like the universe inside a black hole are made possible by this unusual geometry. Furthermore, it makes room for even more amazing phenomena, including wormholes, which are tunnels that would link various locations in space-time. According to some simulations, These tunnels may form spontaneously in areas of twisted geometry, potentially enabling interstellar or temporal travel. These ideas are not at all fantastical. Sophisticated simulation models already demonstrate how some black hole configurations, particularly fast-rotating ones, Kerr, may contain interior structures that terminate in a new area of space-time rather than a singularity. With its own set of physical rules, and possibly even another arrow of time, the geometry in this new area would be entirely different from our own. Therefore, the cosmos might not be space in the conventional sense, but rather a flexible, self-curving structure that can create entire universes with a simple twist of its dimensions. If this is the case, then each black hole is comparable to a fold in the fabric of reality, and we are living in the spaces between them. Have you ever seen the matryoshkas, which are Russian dolls that fit inside one another? Imagine now that the cosmos functions similarly. Many theoretical physicists use this image to explain the idea of worlds inside universes, layered like cosmic layers. Every black hole would serve as a portal to the subsequent level. One of the tiniest dolls, hidden inside a gigantic edifice that we will never be able to see, could be our own cosmos. In addition to being poetically lovely, the concept of nested universes is derived from the mathematics of general relativity. Our world might be contained within the curved interior of a wider reality, invisible to us but crucial to our existence, if each black hole has the capacity to create a new spacetime. According to this scenario, additional black holes would be incubating their own creations within our universe, and the Big Bang would be like the opening of the next doll. A hierarchical multiverse is produced by this layered structure, where the laws of physics might differ between universes. In another universe, within another black hole, things that are constants to us, like the force of gravity or the speed of light, might be entirely different. Every layer has a unique identity and past. We are a chapter in a book that we haven't read through to the end. Our perception of reality is drastically altered by this vision. We now observe a fractal cosmos, a self-replicating endless structure where each point of collapse gives rise to a new expansion rather than a flat, isolated universe. As with matryoshka dolls, the smallest can be the most intricate, and the line between inside and exterior blurs, with what is inside potentially containing more than what is outside. If you think this is over the top, keep in mind that there are black holes that are millions of times as massive as the Sun and can accommodate thousands of galaxies. It makes sense to think that a reality with this much gravitational energy may be expansive, self-regulating, and whole. And possibly, without even realizing it, we are living examples of this, inhabiting one of these enormous cosmic dolls. The final vision is both poetic and unsettling. The universe is not a location, but rather a living structure made up of layers upon layers, where every new collapse is a birth, and where maybe a black hole in our universe will eventually give rise to the next chapter, with other creatures, laws, and inquiries. The notion that space is flat, straight, endless, and predictable is our biggest delusion. But that is not how the universe operates. According to general relativity, space may bend, twist, roll up on itself, and even curve, much like a piece of paper that has been twisted into a tube. Furthermore, that geometry stops making sense when gravity reaches extremes, like within a black hole, giving rise to what physicists refer to as non-Euclidean geometries. An whole cosmos could be contained within a black hole because of these warped spaces, even while the black hole's mouth appears to be modest from the outside. The internal volume within these curving regions can be enormous. It may, in other words, be larger inside than outside. This idea is scientifically feasible and consistent with Einstein's equations, despite the fact that it totally contradicts human intuition. Consider a magic bag to better comprehend it. It appears little from the outside. However, you discover that it is nearly limitless when you reach inside. In a black hole, space-time functions similarly. The universe's fabric is stretched by extreme gravity to the point where inner regions are formed that are totally cut off from the outside world. It's as though you entered a regular door and discovered a whole universe waiting for you beyond. Theories like the universe inside a black hole are made possible by this unusual geometry. Furthermore, it makes room for even more amazing phenomena, including wormholes, which are tunnels that would link various locations in space-time. According to some simulations, these tunnels may form spontaneously in areas of twisted geometry, potentially enabling interstellar or temporal travel. These ideas are not at all fantastical. Sophisticated simulation models already demonstrate how some black hole configurations, particularly fast-rotating ones, Kerr, may contain interior structures that terminate in a new area of spacetime, rather than a singularity. With its own set of physical rules, and possibly even another arrow of time, the geometry in that new area would be entirely different from our own. As a result, the cosmos might not be space in the conventional sense, but rather a flexible, self-curving structure that can create whole universes with a simple twist of its dimensions. If this is accurate, then each black hole is comparable to a fold in the fabric of reality, and we are surrounded by folds. Black holes were thought to be cosmic destroyers for many years. However, a fresh viewpoint is suddenly becoming popular. What if they were, in fact, doors to creation? After all, how can something that sweeps everything into nothingness also be the source of new universes? This may seem like a paradox. However, the solution might be found in the depths of theoretical physics, where black holes become actual cosmic birth machines. Some models, like the one put out by Nikodym Popławski, suggest that black holes can serve as belly buttons between realms. The collapse of matter inside a black hole may initiate a new phase of space-time expansion rather than terminate in an infinite singularity. Instead of devastation, it would mark the start of a new universe, complete with its own laws, timeline, and Big Bang. According to this theory, black holes are cosmic seeds that could each give rise to a new universe. Theoretically, the collapse of a black hole in a larger universe could have produced our own universe in just this manner. And if this is true, then all of the black holes in our universe might be creating new universes, right now, that are entirely unreachable by humans. The fact that this model resolves significant issues in contemporary physics is even more astounding. Consider the information paradox, which is the conundrum that anything that falls into a black hole will be permanently lost. The issue vanishes if information is actually reincarnated in a different universe. Everything is changed, nothing is lost. One universe's entropy may represent another's starting order. This leads to an even more intriguing question. Is it possible for humans to build universes? Yes, in principle. Provided this hypothesis is true, we could build a whole new universe, maybe with its own laws and even life, provided we could make an artificial black hole, which is beyond our current capabilities. Without even being aware that we had made anything, we would be considered gods. Ultimately, black holes become the cradles of entire realities rather than only the graves of stars. Every one of them might have a tale, a place, a period, or even a civilization that, like us, ponders. Where did we come from? And what is out there? The concept of singularity, which surpasses all human comprehension, is at the core of a black hole. It's not simply a tiny point. It's a location where space-time collapses, gravity becomes limitless, and the laws of physics as we know them stop working. Singularity was long seen by scientists as a mistake or a weakness in the equations. What if, on the contrary, it served as the focal point of the entire cosmic mechanism? The singularity, a place where everything that exists is crushed into infinite density, might be the closest thing we can think of to complete nothingness. However, that's exactly where its creative force is found. A star's apparent demise could be the start of a whole universe if our universe was created from a singularity, as the Big Bang theory implies. In that way, the black core of creation is the singularity. The goal of contemporary physics is to determine what actually occurs inside the prohibited core. We get there through relativity, but once we get there, it breaks down. The study of the very small, known as quantum mechanics, aims to explain how particles behave in harsh environments. The issue is that there is now no communication between the two hypotheses. We require a theory of quantum gravity, and singularity is concealed right here, where the infinitely big and the infinitely small collide. Singularity may not be an endpoint, but rather a shift to a different stage of reality, according to theories like loop quantum gravity or even string theory predictions. Gravitational collapse might produce a fresh expansion, a big bang within a black hole, as quantum effects smooth out infinite density. Stated differently, every singularity would represent a cosmic birth, a new universe emerging from chaos. This fundamentally alters how we view the cosmos. The singularity would be a global recycle point rather than an error, a process by which the universe is restarted, reborn, and changed. Everything, including life, matter, and existence itself, could have started there, in a core of blackness so thick that light cannot escape, but so fertile that time itself is born. If this is the case, then researching singularity entails more than merely investigating the boundaries of physics. In order to comprehend how the death of one universe can subtly include the birth scream of another, it is necessary to search for the ultimate genesis of everything. After all, singularity might not be as definitive as it seems, and more like a living heart that generates whole worlds. Radio waves and other electromagnetic signals move at the speed of light through galaxies, nebulae, and possibly even the boundaries of our own universe, creating an invisible symphony that reverberates throughout the immense silence of space. There are hints about what is out there, and, who knows, what is beyond our observable cosmos in these cosmic whispers. Scientists are still trying to interpret the pulses, patterns, and distortions that radio telescopes have recently picked up from very far-off places. These waves frequently seem to be connected to dramatic occurrences like supernova and neutron star collisions, as well as black holes. However, there are instances where the signals lack a clear explanation. They are echoes that don't make sense to us. The idea that these signals might be reflections of events taking on within black holes or in other universes is an interesting one. Some of these radio waves might represent reverberations from the outside, warped by the curvature of space-time and the intrinsic geometry of our reality, if we are indeed inside one of these structures, as some physicists propose. Furthermore, certain black holes seem to release relativistic jets, which are energy beams that are released at nearly the speed of light. It's still unclear where these jets came from. However, some scientists speculate that these are ways of communication or information exchange across various space-time areas, or even between universes that are connected by black holes. Are these jets cosmic messages somehow? All of this is still purely theoretical, of course, but we are increasingly able to interpret these messages from the cosmos thanks to modern technologies. We will eventually be able to hear these waves more clearly and possibly spot patterns that reveal realities outside of our own because to the development of observatories like the James Webb and the SKA, Square Kilometre Array. After all, when we detect these waves, what are we hearing? Do those sounds represent dying stars? When do galaxies form? Or echoes of civilizations in other universes attempting to communicate with the unknown, just like us? One thing is for sure, regardless of the response, the cosmos communicates. We must have the ability to listen. Albert Einstein is credited with permanently altering our understanding of the cosmos. In addition to redefining gravity as a curvature of space-time, his general relativity theory, which was published in 1915, created new possibilities for worlds that had previously only existed in the mind. Black holes were predicted by this theory long before they were ever seen. Furthermore, the notion that space can be dynamic, foldable, and adaptable was sown by this theory. According to Einstein, the cosmos is a flexible fabric. According to his equations, the fabric of mass and energy curves is what we perceive as gravity. However, he went one step farther and suggested that extreme geometries, like those found in black holes, might occur in space-time. Furthermore, when certain geometries are stretched to their limits, they may produce hitherto unimaginable phenomena, like worlds inside other universes. It's interesting to note that Einstein did not think black holes were real. He believed that nature would find a way to prevent such complete collapses, even if he could see his equations going in that direction. He did, however, contribute to the mathematical underpinnings that today support the notion that black holes exist and may hold the secret to the universe's beginnings. Physicists like Carl Schwarzschild, Roy Kerr, and Roger Penrose built on Einstein's theories in the years that followed. They solved his equations that explained wormholes, rotating black holes, and even concave structures of space-time that would link disparate parts of the cosmos. These limitations, like the event horizon, can be understood as both logical and physical, the last line separating what we can know from what is beyond. Today's theoretical physicists are looking for a unified theory that connects relativity with quantum mechanics, something Einstein was unable to do during his lifetime. We are still guided by Einstein's thinking on that last frontier. Black holes, where space curves so much that it can flip back on itself and form something new, may hold the key to the solution, as some assume. The earliest illustrations of the structure of stacked universes may have been made by Einstein without his knowledge. The most potent doubt of all was sown by his theories. What if the world is merely a local expression of something far bigger? If so, the theory of relativity is not the only thing that Einstein left behind. It is the opening of an intellectual door to a world that we can already imagine but do not yet fully comprehend. In a world when everything appears to be uncertain, mathematics is the one language that is unwavering, universal, and solid. And scientists have been revealing the universe's underlying strata through mathematics. Despite our inability to see anything directly, mathematics reveals what exists. Furthermore, every new formula that unlocks a cosmic riddle might actually be exposing universes that are not yet visible to us but do exist. Theories like cosmic inflation, solutions like Kerr-Newman's, and equations like Einstein's all suggest structures that are outside the range of our telescopes. In certain mathematical models, the idea of multiple universes itself naturally arises as a workable, rational, and cohesive answer. Put another way, mathematics is revealing rather than creating. According to string theory, for instance, the cosmos is composed of microscopic vibrating strings that exist in up to 11 dimensions, rather than particles. Curled up into formations so tiny that humans could never directly detect them, the majority of these dimensions are hidden. Equations, however, reveal the implications of these additional dimensions, and some of them imply that parallel realities and our own may coexist with only a thin quantum barrier separating them. Another illustration is hyperbolic geometry, which permits spaces with infinite volumes to exist despite having finite borders. The behavior of one universe inside another, and even the internal structure of black holes can be explained by this equation. Hidden universes would be the obvious result of mathematical reasoning, not science fiction. Mathematical solutions to the relativity equations gave rise to the concept of wormholes. These solutions were never thought of as fiction. Rather, they developed organically from mathematics as potential routes connecting far-flung areas of space-time. And some people are now actively researching if these passageways between various universes could be employed, or even if they are actually happening. The so-called information paradox is one of the most unsettling of the numerous riddles surrounding black holes. No information in the universe can be totally erased, even if it is absorbed by a black hole, according to quantum theory. However, the contrary is true according to general relativity, which states that anything that enters a black hole is destroyed forever, locked outside the event horizon, and ultimately smashed into the singularity, and the contradiction is there. The best physicists in the world, like as Stephen Hawking, have been engaged in a contentious dispute over this dilemma for decades. Hawking first held the opinion that information was lost, but later changed his mind. The topic is straightforward, but profound. What happens to the data that describes an object, a star, a planet, or even a whole encyclopedia, if it is thrown into a black hole? Does it vanish? Or is it somehow encoded on the black hole's edge? Among the most fascinating concepts was the theory of holography. This idea holds that any information that enters a black hole is encoded on its surface, like a two-dimensional projection that contains all of the information that was within, rather than being destroyed. The universe might store its information on surfaces, similar to how a hologram projects a three-dimensional image onto a flat surface. As a result of this hypothesis, Gerard 't Hooft and Leonard Susskind came up with the well-known holographic principle, which postulates that our own universe might behave as a hologram, and that everything we perceive in 3 dimensions is simply a projection of data held on a 2-dimensional barrier. Furthermore, the idea that we are inside a black hole is almost entirely consistent with this one. Our understanding of reality would be drastically altered if this holographic encoding proves to be accurate. We might be patterns of information reflected on an invisible surface, floating in curved space-time, in addition to existing in a closed world. The interface of something deeper and more inaccessible would be reality as we know it. This brings us to the unsettling conclusion that what occurs inside a black hole might not be lost. Rather, it might always be in front of us, encoded in a form that we are still unable to decode. The information paradox invites us to reconsider what is real and what is merely a shadow projected on the cosmic wall, making it more than just a technological issue. What if it's all true? The question of who is on the outside becomes inescapable if we truly live within a black hole, which has its own set of physical laws, bent space, dilated time, and invisible boundaries. And is that possible? Can they see us? This kind of inquiry beyond the boundaries of science and touches on metaphysics, philosophy, and even existential speculation. It is conceivable that there are outside observers, scientists, civilizations, or consciousnesses capable of examining the gravitational pull of our black hole without even being aware that an entire universe exists inside it, given that a universe can emerge inside a black hole in another universe. Perhaps we are being watched on another plane of reality, much as we see black holes in the sky. How would this affect us? Nothing at all from a technical perspective. We are unable to escape our event horizon, see the outside world, or even verify its existence. Thus, we are stuck there. From a philosophical perspective, however, it alters everything. We might be merely a participant in a cosmic experiment or an externally observed physical fact. Even if it is unsettling, this option is not irrational. It is only the obvious result of the physics that we currently understand. Even more intriguing is the possibility that the rules governing our universe are not universal. Like genetic features passed down from father to kid, they might have been inherited from the universe that created us. This implies that the laws governing the cosmos beyond our own might be entirely different. Time could mean different things to them. Perhaps there is no such thing as gravity. Furthermore, what we refer to as reality might simply be a byproduct of a bigger system that is beyond our comprehension. Now consider this. If our telescopes are attempting to investigate black holes from the outside in, what if we were being probed by someone from the outside? Would we be seen? Do we send forth signals? Do any remnants of our cosmos leak out, such as gravitational distortions or radiation particles? Maybe humans are merely a phenomenon that they watch and research, or maybe disregard entirely. Ultimately, this question is still open. Who is on the outside if we are indeed inside a black hole? And have they yet to notice that there are questions, life, and consciousness inside? We might be evidence that life can exist within a black hole. And who knows? Maybe someone is listening to us right now, trying to comprehend what's beyond the last frontier as much as we do. The question of who we are in that enormous setting is unavoidable if everything we have studied thus far is accurate. If our universe is indeed the interior of a black hole, the result of the cosmic collapse of another reality. We are the outcome of something that was merely an endpoint for the parent cosmos, which may be an uncomfortable but incredibly liberating answer. And it was the start of everything for us. This viewpoint radically reinterprets what it means to be alive. We no longer live in a singular, isolated, and absolute universe. We become only one example among many, a layer inside a bigger, invisible framework. The galaxies, the Earth, the solar system. All of this could be a minute detail in a much bigger phenomenon, the origin and intent of which we may never fully comprehend. However, this concept also has a lyrical quality, because we are conscious of this situation, despite the fact that we are so insignificant in comparison. The same substance that creates stars, nebulae, and black holes also makes us. Nevertheless, we are able to pose queries that have resonance in the deepest corners of the unknown. If we inhabit a black hole, we are the very consciousness that emerges from inside of it, the cosmos looking in on itself. Additionally, this alters how we perceive space, time, and even death. The end may perhaps be the start of something new if a black hole's collapse can create a new world. It's possible that the demise of stars, societies, and even entire universes is merely a turning point, similar to doors closing to let others open, a never-ending cycle of creation and destruction. We have always been taught by science to look up to the sky for solutions. Now, though, we might also need to look inward. into reality's very framework, into the rules that give us our existence, into the invisible geometry that creates our familiar reality. Because that is where the hints of our true identities, not only being occupants of a universe, can be found, but a living component of a phenomenon that is not limited by time, space, or even existence as we know it. Furthermore, it's possible that the true query isn't, do we reside inside a black hole? Instead, ask yourself, what can we do with this knowledge? Because our existence is by definition a miracle of the unlikely if we are truly the product of another world collapsing. And just by existing here, asking questions, looking for answers, and producing art and science, we are somehow the solution that the universe itself